Okay, so this is the video, um, the one that has the bonus word or bonus task or whatever you want to call it. So with all these practices, all these review sheets that you've got, you should be pretty um, proficient by the time Thursday comes. Well, without further ado, um, again, we are, if you like, here's my variable m, which is being multiplied by 3, subtract 20, and it's negative 18, so the inverse operation would be plus 20 and divide by 3. So let's do that, plus 20, plus 20. You're going to have a calculator, so you might as well use it if you're home. And, sorry, plus 20. Yeah, plus, I don't know why I wrote plus 18 here, so it's plus 20. And negative 18 plus 20 is negative, it's just 2. Divide by 3, divide by 3, and m equals 2/3. Okay, so now we're going to check. So on our check, 3m minus 20 equals negative 18. And in the place of m, I'm going to put 2/3, right? So I'm going to replace m with 2/3. Let's see if, so this is my check. So 3 times 2/3, let me think about that. We can simplify this, and we eventually have 2 minus 20, and 2 minus 12 is negative 18. And you can see that both sides check out, so we're good. Second question, 3/5 of a equals 30. 3/5 of something equals 30. So here's my variable a, which is currently being multiplied by 3/5. That gives me 30. So the inverse operation we're going to do, instead of the opposite multiplication and division, we're going to divide by 3/5. What does divide by 3/5 mean? Divide by 3/5 is the same thing as multiplying by the reciprocal, which is 5/3. I'm going to multiply by the 5/3 on that side and 5/3 on this side. Well, on the left side, all that simplifies to 1. 1 times a is just a. And on this side, I can put this over 1 if I like, and then I can multiply 30 times 5, which is 150, and divide that by 3. A equals 50. So my check, I'm going to go 3/5 times a, right, which is 50 now, and that's 30. So what's 3/5 of 50? Is that equal to 30 really? Well, I can simplify. Well, if you put this over 1, you can multiply the top. 3 times 50 is 150 divided by 5 is just 30, right? Or you can cross cancel. 5 divided by 5 is 1. 50 divided by 5 is 10. And you can tell 3 times 10 is 30. So again, our check works out. So distributive property has to be done first. 8p plus positive and positive 96 equals 104. The rest again, very easy. So the story says I have a variable p multiplied by 8 plus 96 is 104. I'm going to do minus 96, and I'm going to do divide by 8. So those are the two inverse operations. So minus 96, minus 96. These two go away. 8p comes down, and that looks like 8. Divide both sides by 8. This is nice and easy. P equals 1. So our check. So 8 equals, and again, I'm going to replace the p with 1, so I'm going to go 1 plus 12 equals 104. Inside the parentheses, 1 plus 12 is 13, which we now multiply by 8, and that really is 104. So again, both sides equal each other. Okay. Just take a look at the rest of this review sheet. All right, there's some inequalities. Where are we? On that one. So this one says c, there's a variable c that's being divided by negative 4 and then added to 12, and that somehow gives you negative 38. So if we want to start with that number, we're going to do minus 12 and then times negative 4. So those are the two operations. So let's show subtracting 12 from both sides. This 12 goes away. Negative 38 and negative 12 is negative 50. C over negative 4 comes down. we're now going to multiply both sides by negative 4, right? So we've done this. We got to do this. So multiply this side by negative 4. And multiply this side by negative 4. Negative times a negative is a positive. 50 times 4 is 200. Negative 4 and this negative 4 will cross simplify to become just 1, and 1 times c. So the value of c is 200. So when we do our check, we have negative 4 plus 12 equals negative 38. So I'm going to put the 200 over here. Right, so let's see if that truly gives us negative 38. So 200 divided by negative 4 is negative 50, which add to 12. Does that equal negative 38? Yes, it does. So my left and my right is the same. Translate to equations. So all I got to do is translate. There's no solving here. So I like to translate part by part. Right under it is. So 8 means, 8 is 8. Less than to me is subtraction, right? Twice a number is 2 times, what I mean, multiplying that by a number. I forgot the b here. So 2 times a number, let's call that n. And that equals 17. So am I done? No, because the word is less than, so I have to make a little switcheroo here. The 2n and the 8 will change positions. So my final answer is 2n minus 8 equals 17. 3 times a number, well, 3 times, right? And then it says sum of a number, so sum. Sum means addition. What am I adding? I'm adding a number n and a 7, right? And is negative 5. So 3 times the sum of a number and 7. Well, the sum of a number and 7, so I have to protect that because I have to add n and 7 first, and then multiply that by 3. So in this case, I needed a parentheses. Quotient means division, so here's my division. What am I dividing? A number, n, and negative 3, so I'm going to write negative 3 at the bottom, plus 5 is equal to 12. So again, grammar check here, is equal to 12. And that's your equation. Write an equality to represent your statement. So you must be older than 18. So I want you to show me all the ages that are older than 18. So I'm going to write O for older. So this is my variable. I'm actually going to write the letter C. So in order to get into the club, you have to be older than 18. How do we describe numbers older than 18? Well, they have to be that sign. Not equal to, because if you're 18, you can't get in. You have to be older. So anything above 18. She has to spend at least $10 to get a bonus gift. So to get this gift, well, we're comparing the gift, $10, right? So in order to get this gift, what do you have to do in relationship to 10? Well, whatever I spend has to be greater than 10. I'll get a bonus gift. Or even if it's equal to 10, I'll still get a little bonus gift. Okay, so whatever I spend has to be greater or equal to 10. The maximum number of students allowed is 33. So in this classroom, actually, I think that's the rule. The max is 33. So in this classroom, the letter is C. So the maximum number means that I can have 33 and lower, and it will be legal. You need to get a minimum of 65 to pass the class. So to pass the class, I'll use P, and we're using 65, right, as our reference number. So in order to pass, my grade has to be either greater than 65 or even equal to 65. So now this one says solve graph and check. One's easy enough. I have a variable a, which is being multiplied by negative 3. So the only thing that's going to happen here is that I have to divide by negative 3. And divide by negative 3. Negative 3 divided by negative 3 is just 1. 1 times a is a. On the other side, 15 divided by negative 3 is negative 5. And because I divided by a negative number, what happens to my sign? It goes the other way. So to graph, here's my graph. Negative 5, negative 4, negative 6. Put a circle on top of negative 5. We're not shading it because it's not part of the solution. But any number that's less than negative 5 is part. So again, remember I told you to test the number. So let's put 100 over here. Is 100 less than negative 5? It's not. So I don't want, and what side is 100? 100 is on this side of the world. So I don't want anything on this side of the world, which makes me point the arrow that way. Here's my variable m. And I'll make a story this one because it's two-step. Being divided by negative 5 and then added 10. That's or equal to 20. It's going to be minus 10 and then times negative 5. Those are the operations I'm going to do. So first things first, minus 10 on this side, minus 10 on that side. These 10 go away. M over negative 5 comes down, less or equal, and 20 minus 10 is just 10. Step 2. Well, I subtracted 10 from each side. Now I'm going to multiply both sides. I'm going to multiply this side by negative 5. Multiply this side by negative 5. 10 times negative 5 is negative 50. This negative 5 and this negative 5 simplifies to 1. 1 times m is just m. So again, just like in the previous problem, we were dealing with a negative coefficient, and we divided by a negative number. So therefore, we're going to switch the sign the other way. So m is greater than negative 50. So let's graph this. We got negative 50, negative 49, negative 51. So we're going to put a circle on top of negative 50. We're going to shade it because that's part of the solution. And we want all the numbers that are greater than negative 50. Well, all the numbers that are greater than negative 50. And again, pick a very large number just to see if it works. Let's pick this number right here, which is 100,000. Is 100,000 greater than negative 50? Yes, it is. Where's 100,000? On the left or on the right? Well, that's over here. I'm going to point it. Again, variable is p, which is being multiplied by 4, and then added 10, negative 6. So we're going to do minus 10, and then divide by 4. So let's do that. First thing is minus 10, minus 10. These two go away. 4p comes down, and then negative 6 and negative 10 becomes negative 16. Step 2, divide by 4. Divide by 4. 4 divided by 4 is 1. 1 times p is just p. And negative 16 divided by 4 is negative 4. So negative 4 is less than all these values. So let's do a number line over here. Negative 4, negative 3, negative 5. Put a circle. So again, I want you to put a number in there. Just take a large number, see if it works. And that's going to tell you where to point. So instead of p, let me put 100 over here. It's negative 4 less than 100. Yes, it is. And where's 100? On the left side or on the right side? Well, 100's over here. So that indicates to me that I want all the numbers this way. Okay. I need to pause because I'm hungry. So I think we're on this one. It's a my variable is a, which is being multiplied by negative 9. I'm going to add 12 to it. It's going to be greater than 21. Going backwards, I'm going to use the inverse operation, minus 12, and then divide by negative 1. So these are the two operations I'm going to show. Be very careful here. So minus 12 and minus 12 on each side, right? So I'm going to separate my inequality into the 2 halves. 12 minus 12 is just 0, so that goes away. Negative 9 comes down, and that's greater to 21 minus 12 is just 9. So the second thing we do right now is divide by negative 9, and then divide by negative 9 on both sides. Negative 9 divided by negative 9 is just 1, and we're left with a. On the other side, 9 divided by negative 9 is just negative 1. But because we divided by a negative number, our sign is going to, aim the other way. So my graph, let me make a graph here. So I want the circle on top of -1. I'm not shading it. And I want to know, what if is it numbers to the left or numbers to the right that will make that inequality true? Well, let's, like I said, do a test number here. So let me pick 100. Is 100 less than -1? No, it's not. So where's 100? 100 is on the right side. So it's telling me that I don't want numbers on this side of the row, which means I'm going to point the arrow that way. Okay. 5. Sam rents a car for 1 day, charges $28. So what are we? Oh, these are equations. Okay, so I know my equations don't look like this. I have an equal sign. Okay. He charges $28 plus $15 per mile. Alex wants to spend exactly 50. How many days can he rent a car for? So, charge 28, so it's 0.15 per mile. What? Hang on a sec. Something missing here. Charges $28. And spend exactly 50. Well, this question is silly because it's only 1 day. Right? The charge itself is $28. So how many days can you rent a car for? You can only. So do me a favor, ignore this question. There's a lot of information missing, and it's not how I want it to be. So I'm going to cross that question out. Okay. Next one, Gary went to the hobby shop and bought 5 kites for $9.95 and a few balloons that cost 75 cents each. He spent a total of 55. So I'm going to write equals 55.75. So what did he spend? What was equal to 55.75? 5 kites. Well, $9.95 each. So 9.95 times 5. Alexa, what's 9? That's 50. 40.75. Is it?
9 plus 5,040.75.
I did not ask that. So that's 49.75. So all the kites that he bought, he spent $49.75. Then the rest he spent on balloons, but we don't know how many balloons. Plus 0.75 cents per balloon. And that's our equation. So according to this, I'm going to have to subtract this first. I'll subtract this from this side. Right, 49.75. These two go away, then I'm left with 75 cents. B equals 6. And now divide by 0.75 and divide by 0.75. And I'm going to get that I bought how many balloons? 8 balloons, exactly. Okay. Oh, I'm sleepy. Natalie won 91 bouncing balls playing basketball at the county fair. At school, she gave 3 to every student in her math class. She has only 1 remaining. How many students are in her class? Well, what do we know? We know that there were 91 bouncing balls. So she gave a bunch to her classmates, right? 3 to each classmate. And that's, instead of students, I'm going to call it classmates because I'd rather write C than S. So every student, the unknown is classmates. What do we know about the classmates? There's a relationship with classmates and the number 3 because each classmate got 3 balloons. So she gave 3 balloons to everyone, all the classmates, and then after doing all that, there was 1 left over. So all the balloons she gave, plus the 1 left over that she has, it equals to 91. Right? So we can use this equation to find out how many classmates, or how many students were in the class. Well, minus 1 from each side. 1 plus 1, 1 minus 1, that goes away. 91 minus 1 is 90. 3C comes down, and we can already see what it's looking like. 3C, we're going to divide this by 3, divide this by 3, and C equals 30. There were 30 classmates in your class. For a field trip, 5 students rode in a car, and the rest filled 10 buses. Okay, how many students were in each bus? If 215 students were on the trip. So here, the total students was 215. What do I know so far? I know that there was one car with 5 students. So in the car, and I'll write car over here, there were 5 students. And then how many buses were there? Well, there are 10 buses, and how many students were in each bus? Well, we don't know, so that's why I'm going to write 10 times S for students, right? And all that has to equal 250. Minus 5, minus 5. These two go away. I'm going to get that 10S equals 210. Divide this side by 10, divide this side by 10, and S equals 21. So how many students were in each bus? 20. Gotta give you your password. So your word is gonna be 3 words. Your bonus word is gonna be 3 words. So the first one is Olympics. Olympics. That's your first word. Olympics. Adam rents bikes for $19 plus $8 per hour. Nicole paid $67 to rent a bike. For how many hours did she rent? So just to get the bike, so let me re-explain this question. So just to get the bike, it's 19 bucks, right? To take the bike. Now after that, they still charge you $8 per hour. So Nicole paid a total of $67. So what do I know so far? I know that she paid $19 to use the bike, for the right to use the bike, and then she took it out, for a few hours. So how many hours? Well, that tells me that my variable is h, and there's a relationship here with the 8 per hour plus 19 equals 67. Minus 19, and I'm gonna write it over here. 8h equals 7 minus 9 is 8. And what is this? 5. 5 minus 1 is 4, 48. Divide both sides by 8, and h equals 6. So the number of hours that she rented the bike for was for 6 hours. Tom bought 3 something yellow balloons and 4 blue balloons for $3.50. All the balloons were the same price. What was the price of one balloon? Really? So I know that there were a total of 3 plus 4, 7 balloons. 7 balloons here. 7 balloons, all that equal to $3.50. Now I want the price of one balloon. Well, divide this side by 7, divide this side by 7, and I get the price of one balloon was 50 cents. So Ben rents a car that charges $20 per day plus 12 cents per mile. He needs to drive the car for 200 miles. The maximum he can spend is 70. How many days can we rent the car for? So let's see. I know, so this says it's an inequality, first of all, so be really careful. The max he can spend is 70, so whatever I'm getting here has to be less than or equal to 70. So what do we know for sure that he has to spend? Well, I don't know how many days yet, but I know that he has to travel 200 miles. And each mile is 12 cents. So I'm going to multiply that. Alexa, what's 200 times 0.12?
200 times 0.12 is 24.
So he's going to pay $24 just for the miles that he's driving. Plus, he's got to pay for per day, right? So how many days? So days is my variable. And how much is it per day? It's $20 per day. So $20 per day plus the $24 that he's going to spend for the miles, for the 200 miles. That should all equal to less or equal to 70. Well, minus 24, minus 24. These two go away. I'm going to get 20D less or equal to 46, right? Divide by 20, divide by 20, and D is going to be 2.3. So less or equal to 2.3. So the maximum number of days, so if I graph this, right? So if I graph this, can he rent a car for 3 days? No. What's the max he can go? The max he can go is 2 or less, right? Here's a second word. Olympics was the first. Second word will be, oh yeah. Here's a second word. Tokyo. Daniel has 15 to spend at the fair. The admission at the fair is $2.50 and the rides cost at $175 each. What's the greatest number of rides that Daniel can go on? Well, he has $15. Can he spend more than 15? No. So anything less or equal to 15 is fine. So what do we know for sure? Well, he has to pay $2.50 to get in. So plus, how much is each ride? $175 per ride. How many rides can you go on? I'm going to subtract minus 2.5, minus 2.5, and I'm just going to write it over here. So you're going to get 1.75 because these two go away. Once the 75R comes down, less or equal to, and 15 minus 12.5 is 12.5. We now divide both sides by 1.75, divide by 1.75, and let's see how many rides he can go. Alexa, what's 12.5 divided by 1.75?
12.5 divided by 1.75 is 7.1429.
7.14. So he has to go, well, that's the actual answer, right? But in context of this story, what's the greatest number of rides he can go? 7, right? Or, yes, you can go 7, 6, 5, 4, 3, 2, 1, but the maximum is 7. The 7th grade class is putting on a show to raise money. It costs $700 to rent the banquet hall. They charge $15 per ticket. How many tickets do they need to sell in order to raise at least 1,000? Alright, so they need to make $1,000 or more, so that's going to be represented by this, right? You don't want to make less than 1,000. You want to make anything 1,000 or more. So in order to do that, hang on a second, something is not right over here. This one is actually simpler. They want to raise $1,000 or more. What are they doing? They're selling tickets for $15. So 15T, that's it. That's how they're going to get their money. They're not selling anything else, right? They're just selling tickets. So 15T has to be greater than 1,000. And let's see how many tickets they need. So divide both sides by 15. The number of tickets that they need to raise $1,000. Alexa, what's 1,000 divided by 15?
1,000 divided by 50 is 20.
Why don't I use Alexa? 1,000 divided by 15 is 66.66666 forever and ever. So bar notation over here. So if they sell 66.6 tickets, they'll make $1,000. But can you sell 66.6 tickets? No. So in the context of this story, the greatest number, right? So if this is your answer, the greatest number they need to sell, the greatest number of tickets, the smallest amount of tickets that you sell has to be greater than 67. So 67 or greater. And then Trinity had $600 in the savings account at the beginning of summer. She wants to have at least $250 in the account by the end of the summer. So it means she doesn't want to spend everything, but she does have to eat and have a little fun. So she spends $35 each week. So without having to spend everything, so how many weeks can she go and spend $35 per week so that she at least has $250 left over. So she doesn't want to spend everything. So in her bank account at the end of summer, she would like to see $250 or more. So it's going to be, well, in this case, 600 that she had initially, minus the $35 that she spends per week, should be greater or equal to 250. Well, let's see how that works. Well, so again, it's going to be minus 600 here, minus 600. These two go away. Negative 35W comes down, greater or equal to negative 350. We divide both sides by negative 35, divide by negative 35. That crosses away, and W has to be greater or equal to 10. So for the sign is the other way. So again, it's a really bad question the way I wrote it, guys, so I apologize. Because it says, for how many weeks, what's the most? What's the greatest? So the question should be, what is the greatest number of weeks that she can spend, $35. So it's not greater than, it should have been less than. So up to 10 weeks, she's okay. If she spends another $35 after 10 weeks, then she's not going to see 250. She's going to see an amount that's less than 250. Okay. So hopefully I didn't make a mess out of this one. So that's going to, oh, I need the last word, right? So I think we have 1, 2, and the last word is going to be summer. Okay. So nice and easy video. I'll try to make the other one too, the one that you were working in class today.